So welcome back. Today we've got Luke here to talk about the Student Advisory Board. That's the Computing Student Advisory Board. Engineering has a Student Advisory Board, but we have one for the School of Computing. It is student-led, and they're looking for leadership and volunteers. So I'll hand it over to Luke here to talk about it.
Hi guys, I'm your TA, but I'm also the head of the Student Relations Committee on CSAB. And so what CSAB is meant for is to help build the School of Computing, take feedback for classes, and to kind of just build a community that everyone can have fun and enjoy. Right now, we are currently recruiting for new members. So I had a whole thing typed out. But so, we meet every Wednesday at 6:30. We're gonna have pizza meetings, and essentially the way it works is we're gonna catch up for like the first 10 minutes of meeting, and then for like the next like 30 minutes or so, we're gonna split into two committees. My committee is the Student Relations Committee, where we help advertise for the different events that the Event Plan Committee is doing. Believe it or not, the Event Plan Committee plans events. But so what we're trying to do this semester is each person in the Event Plan Committee gets to kind of plan their own event and help run it with the Event Plan Committee head kind of helping logistically with it. And so this will help you kind of build like the soft skills that employers are kind of looking for right now, because most of them already expect you to have the technical knowledge. They're looking for people that are able to work in teams and work well with others, essentially. But yeah, that's the big thing. We do a Food for Thought event where we invite everyone from the School of Computing to come and share their experiences in the different classes that we offer. And then we turn around and give that feedback to faculty like Burke, like Whitty, Bone, and help try and solve the problems that some students are encountering for some of the classes that are being taken. That's the big thing. We have a website. It's csab.unl.edu. Everyone in the School of Computing is open to apply, so majors or minors. And then on top of that, we're also doing bubblers for everyone that fills out an application. The application takes like 5 minutes. It should actually work now. And then we will review applications on a rolling basis. I think we're reviewing them this week, so if you can get them in before Wednesday, we'll be able to take a look at it and we'll let you know if your application was accepted. We're also handing out bubblers to everyone that fills out an application. So I'm your TA, so I'll be at the lab section on Wednesday. If you fill an application, come to lab and I'll give you the bubbler. But yeah, that's about it. We're also doing elections at the end of this semester. So if you want an awesome leadership position for your resume, that'd be a kind of a good reason to apply. Anyone have any questions?
What is a bubbler?
It's a small energy drink. It's like 70 milligrams. Okay. It's pretty light.
All right.
People like them for some reason. I don't.
All right. Fair enough.
But, yeah. Thank you, guys.
Yep. csab.unl.edu.
Highly recommend. It's such a low time commitment. It takes like 45 minutes every week.
And I'll add that CSAB is also responsible for, or historically they've put in curricular changes. I think I mentioned it before, but it used to be that you were required 4 years of a foreign language in high school, and then you were out of it. But now it's down to 2 years. So if you take 2 years, I forget what the entrance requirements are. Maybe it's 0, but maybe it's 2. I don't know. But we've reduced that so that you can take more technical stuff, and you don't have to take 16 credit hours of foreign language anymore. All right, so remember what we were doing last time? We created this stock class and a savings class, and then we put them into inheritance hierarchy that looks something like this. At the top, we have an asset, and the commonalities, the account number, the owner, that's all been put up into the superclass. Then down here, we've got more specific, specialized behavior, a balance and an interest rate for a savings account, a num shares and share price for stocks. However, what we were working on before we left was I want to know what the value of this asset is, right? And so if I put that up into the superclass, I could, of course, return a dummy value. I could say return 0, right? That by default, an asset doesn't have any value. Or I could return, because I changed it into a big D double, I could return null, right? That there truly is no value, right? It's null. Or I could throw an illegal state exception here, right? And that's what I'll leave it as for now. Let's come over here to the savings class, and let's override that method now. Remember, it's always best to have the override keyword, even if you don't need it. Public double get value. Now, what is the value of a savings account? Right. Remember that what do we have here? We have a balance and an interest rate. The interest rate is over time, so that's not relevant. The only thing that's relevant here is the balance. That's the value of it. Return this dot balance. Now you might be asking yourself, well, yeah, we already have a get balance method up there, right? Why do we need this get value? And I'll show you here in a second. It's to make sure that you're unifying this entire hierarchy into one thing so that you can treat them all the same, right? And what else do we need? Public double, I guess it's a big D double. I changed it to big D double. There we go. Right. Now tell me what I would do over here in the stock class, because there is different behavior here. What is the value of a stock class? Return this dot num shares times this dot share price, right? So if you have 100 shares of Google stock at $50, then you have $5,000, 50 times 100. Right? Now let me come over here to my demo class. And first of all, let me go ahead and create another asset here. Asset A is equal to new, or I'll call it generic, right? Is equal to new asset, right? Of A, B, C, D, right? And I own it, and that's it, right? Remember when we did this originally, right? I was breaking encapsulation. I was locating behavior, that is multiplying the number of shares by the number of the share price outside of the stock class. It sounds like that's a stock thing to me. Where does it belong? It belongs in the stock class. Right? What about a savings account? What's its value? Well, that's a savings account thing. Where does it belong? It belongs to the savings account. Right? Anyway, I want to treat them all as generic assets because what I want to do is I want to put this into a portfolio, a list of assets. Right? My portfolio, right, is equal to new array list of assets. Right? Now, if I didn't do it as an asset, I couldn't add all of these things into it. For example, what I can do right now is I can say my portfolio dot add generic, and I want to do the same thing for stocks and my savings account too, right? So my savings, that should be fine, but my stocks, can I do that? Yes. Why? What is this a list of? It's a list of assets. What is a stock? It is an asset because of this inheritance hierarchy. If I didn't do this and I treated them all as separate types, I wanted to create a list of stocks. Now everything breaks. You cannot add a savings account to a list of stocks because a savings account is not a stock. Right? It doesn't fall into that inheritance hierarchy anymore. Remember that was called an invariance. Let me bring this over here. Right? I'm trying to treat a stock as a savings or a savings as a stock. Whereas if I had treated everything as a bird, right, then I can make them all migrate at once. Or in this case, I can add them all to one list called my portfolio. And so let me go ahead and add that asset. Right? Now let's go ahead and add them up. What is the total value of my portfolio? So double total is equal to 0.0. For asset in the collection my portfolio, right, I want to say total plus equals asset dot get value. Right? Now if I had not defined that value in the superclass, right, then I would not be able to do this. Right? Let me show you. Let me come over here and I'm going to go ahead and get rid of the value temporarily. Everything breaks. Right? First of all, there's no value to an asset anymore because it's not there. And also this breaks over here because I'm no longer overriding these things, right? Because that's not something that is in the superclass. Let me go ahead and get rid of override, right? If I did it this way without the value in the superclass, what would I have to do? Right? I would have to force it to become the supertype. We call that a contravariance. I want to know how does an ostrich move? They walk, right? Or what does a dog say? They wolf, right? I would have to force this bird to become an ostrich. Well, how do I know that an asset is a stock or a savings, right? So if the asset is a savings account, then I can force it to become a savings account, right? What I could do is say savings S is equal to savings of asset. And then I can add, right, total plus equals asset dot get value. Now, predict what this is going to look like if I continue on doing this. Else if. In other words, anytime I want to add a new subclass, we're going to do this eventually, like crypto or an annuity or something like that, I would have to come back and do what? Add another else if, I would be breaking every single piece of code except for that which is relevant to one of those new assets, like crypto or annuity or whatever, right? Now, the way that you would do this, by the way, and I'll mention it now, if asset instance of, savings? Right, there we go. Instance of is one word, there we go. And I can do it that way. Now it compiles. Let me get rid of that for now, right? How would I do it for the rest of it? Asset. If the asset is an instance of stock, then I could force it to become a stock, right? Remember that this is contravariance, right? I can't just take a robin, treat them like a bird, and then force them to become an ostrich because that's an invariance. This is a little bit safer because I'm asking, is it an instance of a stock? And if so, then you can force it to become a stock. So that you can call this get value method. All right, there we go. Are they not public? Get value. Why are you complaining about these? Oh, S and S. There we go. There. I was still looking at the superclass there, right? So else if, else if, else if, else if. Does that sound like a good pattern to follow? Definitely not. Right? And by the way, the instance of keyword, we'll talk about that in a moment. You never use it. If you find yourself using it, then you're probably doing something wrong, just like I'm doing something wrong right here. Right? There is one instance in which you can, and in fact you have to use the instance of keyword, and I'll talk about that later. It's when using copy constructors. But what I want to do is I want to return this to the very simple code here. Come back over here to asset and restore this method so that all of the subtypes can inherit it, and I can treat it as the supertype. Now what's going to happen here? I forget what the values are, but I've got $5.25 in my savings account. I've got, what is it going to be? $24,000 in Microsoft stock. Ah, nice. Right? So I should get, what, $24,005.25, right? Except that what happens when I look at that generic asset there? It throws an exception, right? I don't know what my value is. So let's come back and save that, or improve this, okay? So what is the value of a generic asset? I don't know. Do you? No, I don't know. Nobody knows, right? So what we're going to do is we're going to make this into an abstract method, right? Right? It is way too generic. It is way too abstract to be able to determine what the value of an asset is. Now, if you're going to do that, you have to make the entire class abstract. Only abstract classes can have abstract methods, right? And then I don't have to provide a function body. I just use a semicolon, and that's it. What that does is it sets up an interface. It says that all assets have this method called getValue. But in the subclasses, those are overridden to provide specific behavior, right? Override. Right? This is not an abstract class. You can call it a concrete class. That's the antonym of abstract, but we generally don't use that terminology, right? But now we can actually provide an answer to that question. That has some implications over here in my demo class. I am no longer able to create a generic asset anymore, which is a good thing, right? Over here with birds, if I just had a generic bird that had move methods, like a robin was overridden to fly, and an ostrich was overridden to walk, right? What if I just had a generic bird? Is there such thing as a generic bird in the real world? No, every bird is a species of some sort, right? A specific species. There's an idea, a generic idea of a bird, but there's no actual bird, right, out in the wild. Just like over here, there should probably not be a generic asset, right? I need to know what the value of these assets are. So by making it abstract, I am prevented from creating these things to be able to answer that, because you don't have an answer to the question of what's the value, right? Nice. And now I can get rid of it down here too. Okay. All right. And it'll work now. And I've got, what was it? Oh, I guess I haven't printed it out. System.out.println. What is the total? What did we say? $24,005.25. Yay, got it. And I was able to treat everything as this one type, this asset type. If I didn't do that, I would have to have multiple lists, a list of stocks, a list of savings account, a list of. As one final thing here, let's come back and fill in the blank now, right? Remember the design sanity check. If your system is well designed, then the addition of a new type should only result in one new class. If your system is poorly designed, or your inheritance hierarchy is poorly designed, then the addition of a new type would lead to many code changes, right? So that else if that I was doing, I would have to change that everywhere that I'm asking questions about assets. Let's go ahead and create a new class here called, do I want to do crypto or annuity? Crypto? All right. Don't care. Anybody own Bitcoin? Ethereum? Anything? I don't either, but if you'd bought it way back when, then You wouldn't be here. You'd be on a beach somewhere. All right, so when you're generating these things, you can actually automatically put in what your superclass is right here, so that it'll generate some code for you, right? That you have to say what the value of this asset is. Well, crypto, say, or Bitcoin or something, public, or not public, but private, right? Double num coins. You can own 1.5 Bitcoins, right? But then also, what is its value in terms of dollars? You have to have an exchange rate. Then the number of coins times the exchange rate, that's your value, right? Return this dot num coins times this dot exchange rate. Now that looks eerily familiar to a stock, which is the number of shares and the share price. Right? But they're not the same thing. I do not want to treat a crypto like a stock and a stock like a crypto, even though they have two double variables who you multiply them together to get a value. Variable names mean things, right? This is modeling a real world thing. A num shares is not the same thing as the number of coins, right? Even though, I mean, it's mathematically it ends up being the same. All right, let's go ahead and go up to, where's all my stuff up there? There we go. Source, generate constructor using fields. There we go. And this will generate a constructor for me that takes care of all of those things together. And now over here, I've only added one new class. Did I have to touch anything in the savings class? Nope, because of invariance, right? If I did that, then it violates that somehow, right? Did I have to change anything in the superclass? No, right? Because it was a well-designed inheritance hierarchy. All I have to do now is create a crypto. My BTC, Bitcoin, is equal to new crypto, and I don't know, BTC 001. I'm the owner. Let's say that I own 10 Bitcoin. That's awesome. Why? Because what's the Bitcoin exchange rate? Right now, I think it was $70,000 or something. Right? So now I've got, it went up since last class, since just this morning. Right? So there's my Bitcoin. I'll add it into my totals. I didn't have to change any of the code down here at all. I just had to add it to the collection. Run this, and guess what? Now I'm much richer. Right? Now I've got near 1 million now, right? Cool. Right. So was it well designed? Yeah, because we only had to introduce that new class and use it. Okay. All right. Questions on inheritance so far? No? Okay. Then let's make some observations. Let's see what observations here. Okay. Yep. Let's go down here. There. Give myself some more room there. All right. So if a class A extends class B, then A is called the subclass, B is called the superclass, and we use that extends keyword. Inheritance defines an is a relationship. A dog is an animal. A cat is an animal. An animal is not necessarily a cat. It's not necessarily a dog. And it is never the case that a cat is a dog. That all gives covariance, invariance, and contravariance. However, you really need to think about your inheritance design. Right? For example, there are some persons who have directed and written books. Right? So would it make sense to make like author, director, and person, right? Into an inheritance hierarchy, right? So I'm going to ask that question, right? What would it look like first, right? If I came over here and I created a class called director, there we go, and I extends person. Right? Well, what kind of things would go to director that are not necessarily in the person up here? What makes somebody a director? Yeah, they've made movies, right? So a list of films. Now, of course, I would need a film class and stuff like that. I'll just go ahead and leave it like that, though. What about a writer? Like a writer of books, right? Writer, and that extends person as well, right? And then they would have like a list of books or whatever, right? Private list of books. There we go. And we'll bring that in. All right, import that. We already have books there. This is just complaining because we have to create a, come on. We have to create a constructor, but once we've done that, we're good. Constructors usually go after that, so there we go. That's a little bit better. And then this one also needs a constructor. There we go. All right, so let's go ahead and highlight those. Remember plant UML over here? That will diagram all these things. There's the director, where's my person, and then what else did I do? Writer, right? So at first glance, that seems like a good idea, right? Because a director is a person, a writer is a person. But what if you had, I can think of two examples. Michael Mann, anybody know who he is? All right, everybody knows who Stephen King is, right? All right, so Stephen King, he's a prolific writer, right? Lots of horror novels. He's also a director. He directed an excellent film called Maximum Overdrive. If you've never seen it, watch it. It's a wonderfully terrible film, right? So yes, he is also a director, right? How would I create an instance of Stephen King then? Let's come over here to demo. So Stephen King is equal to new ... I'll just leave it blank there. Are they a person? Yeah. Are they a director? Yeah. All right, well, let's go ahead and create them as a director. New director, Stephen King. There we go. Because they directed that one film. But now I want to treat them as an author, a writer, right? Did I call it writer? Writer W is equal, Stephen the writer is equal to writer of Stephen King. Can I do that? Stephen, if I spell it correctly, there we go. All right. Yeah, it's telling me that I can't. Why are you not? Okay, let's go ahead and treat him as a person. There we go. Now it'll let me do that. Okay. What's the problem with that? Go back to my diagram over here. Over here we have a robin that I'm treating as a generic bird. Can I then force them to become an ostrich? Nope. That's an invariance. Okay? So you have to be careful. Not everything belongs in an inheritance hierarchy, right? Not everything makes sense to put into an inheritance hierarchy, right? Be judicious. Make sure that your inheritance hierarchy that you're defining makes sense, right? Generally, what we're going to do in this case is we're going to prefer composition over inheritance, right? So this is a perfect use case here. Right? What I'm going to do is I'm going to come back over here to the director, and I'm not going to say that they extends person anymore. They are a person, and I don't want to repeat myself. So what I'll do is I'll do this by composition. Private person. Right? And then also a list of films that I'll promote back up here. There we go. All right. There. Now, what does it look like? All right, let me do the same thing for writer. Right? We've got books, and they own via composition here, private person. There we go. And I'm going to remove this from the inheritance hierarchy. Now, what is writer, person, and where is my person? There we are. And director. Now, what do they look like? There is still a relationship here, but it's no longer in an inheritance hierarchy. Right? In fact, they've been inverted here. The director comes up here and the writer comes up here. Right? They are persons by virtue of them owning by composition an instance of a person. I could then have pass-through variables like, for example, get the last name, public string, get last name. Return, how would I end up doing it? This.person.get last name. Right? So this is what's called a thin wrapper. I'm taking one class and I'm wrapping it up into another class, and then you can still have access to that that inner class. It's not an inner class. That class that's inside that person class. It's just that I'm going to control access through it by these getters. Right? Now, is a writer a person? Well, not in the sense of a hierarchy inheritance, but I still have enough data to say, yeah, there's their last name, there's their first name, there's their date of birth, etc. Right? And you've got a completely different inverted kind of relationship there, right? So remember that there are three relationships that you have to keep track of, right? Covariance is a covariant relationship is always safe. You can take a subclass and you can treat it as a superclass. Contravariant relationships can sometimes be safe, right? You can treat a subclass treat a subclass as a superclass. That's wrong. That's backwards, I think. Contravariant relation. You can sometimes treat a superclass as a subclass. An animal is sometimes a dog, and this is sometimes safe. But an invariant relationship is never safe. You can't take a dog and force them to become a cat or vice versa. All right? All right, so those are the three types, okay? Remember that I said that there is this instance of keyword, right? You can use the instance of keyword to check to see, is my contravariance taking the supertype and forcing them to become a dog? Is it safe by checking first to see if they are a dog, right? And you can use this instance of keyword to do that. However, you generally don't want to do this unless you absolutely have to, right? It is almost always wrong, right? The one time you have to do this is when you are making copies, right? In other words, copy constructors, okay? And you're going to have to do this in your project, which is why I'm pointing out this one instance in which you're forced to do this. And that's because in Java, and in fact in any object-oriented programming language that I know of, there is no such thing as a polymorphic constructor, right? So for example, let's come back over here to the asset class, or sorry, my demo, right? And I've got another Microsoft account, right? My stonks 2, right? And it's a different account, so I'll go ahead and put in 5, 6, 7, and 8. And instead of owning 100 shares of Microsoft, now I own 50 shares and they have the same value there, okay? That's kind of a lot of repeated code though, right? What if I wanted a copy of it? Do we remember that pattern that we showed, that isotope pattern, where I want a new sample of that isotope with its mass change, but everything else stays the same, right? Let's go ahead and create what's called a copy constructor over here in the stock class, right? And to do that, I create public stock. And for now, I'm just going to say stock as I'll copy over everything except for the num shares, right? This will be a different number of shares. Double, there we go. So this dot account number is equal, num shares is equal to num shares. This dot account number, nope. I guess I should have called super first. There we go. And then s dot account number, I guess it's dot get account number. There we go. Dot get account number. S dot get owner. There, I'll pass those up to the superclass. And then this dot share price is equal to s dot share price. There. There's my copy constructor. How would I do that over here if I wanted to copy everything over? Right? For example, what if I treated my stock class asset? There we go. My stock. I'll go with Microsoft here. Oh no, I'll leave it like that, right? And what I want to do is I want to create a copy of that asset. My stock copy is equal to new stock of the old stock. My stonks, and then there's only 50 shares here, right? Can I do that? What does this copy constructor take? It takes a stock. What is my stonks? It's an asset. Right? I don't know that it's a stock class. So what I could do is I could force it to become a stock class. Except, is that safe? What if it were a savings account or a crypto account? This is the one instance in which you can and have to use instance of. If my stonks instance of stock, then it is okay to do this, right? Else if, and then my stonks is, you know, if this are generic, just a, right? I wouldn't know what it is at all, right, from the name. There we go. else if a instance of savings, then you have to force it to become a savings account instead in order to copy it. We don't have a copy constructed there, and I don't want to do that, so instance of, there we go. So to do, right? Now it's all safe and it compiles. I will not have an exception, class cast exception thrown here because I've checked to see that it's a stock class. This is the only time that I should ever see an instance of here, right? To check to see if you need to make a copy of it, all right? Okay, that's the one time, right? If you find yourself doing this often or in other situations, it is most likely a very bad design, right? Generally, you only use instance of when you have to, and do a contravariance is when you have to make copy, contravariance. I guess that's not a word that my spell checker recognizes. It is spelled correctly, right? So in summary, right? Why in summary, right? Inheritance provides a way to do code reuse, right? We already know about code reuse because if you have a piece of code, you put it into a function, you can reuse that function. If you've got a piece of code that needs to be repeated, you put it into a loop so that you can repeat that code, right? You don't hard code it 50 times, right? You would like code reuse. And now code reuse is being done on a data scale, on a class scale, right? It also provides a way to reduce redundancy. If I had repeated the owner in 3 different classes, that's a bad way of bad design because you don't, DRY, don't repeat yourself. It provides a way to reason about and organize classes into a hierarchy. You might have had some biology in the past. How are organisms, biological organisms, how are they organized? Anybody know? So, King Philip, what is that? What is the rest of it? Kingdom, phylum, order. There's 7 of them. Something, something, species. And then down here is the species. We as humans like to organize things because there are billions of organisms out there, right? And we need to organize them so that we don't, we can't concentrate on billions of things at once. We put them into a hierarchy in order to organize them so that we can concentrate on one thing at a time. All organisms in this phylum lay eggs or something, right? And then you go down to the species level. We do this in business, org charts. Large organizations are, organized under a CEO at the top, and then directors, then managers, then people, right? It provides a way about how to organize and reason about your code if it's very, very complex. It is well designed if the introduction of a new class does not break any other code, right? So keep that in mind, right? Some other observations here, all right? In Java, you can create an abstract class, right? What that means is that you can use the abstract keyword, right? And it creates an abstract class. That means that you can have abstract methods with no default behavior, no method body at all, right? Because I don't know what a generic animal says. I don't know what a generic asset, what its value is. Then subclasses will inherit that abstract method, and you must provide an implementation. Right? As a consequence, even if you have a constructor, you cannot instantiate an abstract class, and that's a good thing. You can go a step further here, and you will in your lab this week. You don't necessarily need to for your project, but you can take this a step further and define what's called an interface. An interface is a pure abstraction, right? It's an abstract class with no default behavior at all. All of its methods are abstract. This allows you can in your class you can implement multiple interfaces. Let me show you an example here. All right. This is similar to what you're going to do in your lab this week. But consider the following. We've got 2 types of employees. Some of them are paid hourly and some of them are salaried. We also have interns, though, that are not paid. So instead of putting them into this hierarchy where I would have to return 0 for their pay or throw an exception, I'm going to make a payable interface. Now, employees are payable, but interns are not, right? And consequently, everything in this hierarchy now has to have a how much do I pay them method, right? But there are things that are not people, right? Suppliers. That's another company. We do have to pay our suppliers, otherwise they don't supply us with what we need. Right? So I will put them into this hierarchy by saying that they are payable, right, with this interface. A person, an intern is a person, and all my employees are persons, but a supplier is not. So it makes sense to make this into an interface. What does that interface do? Well, maybe they have a get first name, maybe they have a get last name, maybe they have a get identifier, right? It also means that I can implement multiple interfaces. An employee is both a person and they are payable. I would not be able to do that with abstract classes or classes because Java is a single inheritance hierarchy. You can only extend one class and that's it. But you can implement multiple interfaces, as many as you want. Here's another much more complex view of interfaces, abstract classes, and classes. Some of these things you'll recognize: an array list and a hash set, right? Down here at the bottom, we have all of these classes. These are concrete classes that you can actually use. 2 of them you've used before, right? The others you'll use later. Above that, we have abstract classes. They provide a little bit of abstraction, but also a little bit of default behavior, right? But we still don't know how to implement everything. Up here, we have pure abstraction. No behavior is defined up here at all. In fact, some of these don't even have behavior, right? Some of these, like random access, they define properties instead of behavior. The only thing that provides random access is the array list. Do we remember what random access is? Especially from the C background? If I have an array and I want to access the 10th element, it's at index 9. How do I jump there immediately? It's an array of integers, hint. How many bytes are in an integer? 4 times 9 is 45. I've got a memory address. Go 45 bytes over and you're there. That's what's called random access. You can jump to that location instantaneously, basically. Not instantaneously, but for a very, very cheap computational cost. Can you do that with a linked list? We haven't talked about linked lists yet, but basically there is a node and it's linked to the next node, the next node, the next node. You can't jump to the 10th node. You have to start at the first node and traverse to the 10th node. It's going to cost you 10 operations to get there, right? Instead of 0 operations, okay? Or 1 operation. Some of these things like serializable, clonable, everything has those, and that, again, it's an interface. But it allows you to create a more complex landscape, just like you would create a landscape of organisms with, does anybody look it up? King Philip? Oh, nobody looked it up, bothered looking it up? Anytime I think about it, I've got to look it up. All right, so kingdom, phylum, class, order, phylum, genus, and species. And what is the mnemonic device? King Philip, something, something, something. I don't remember, but anyway. It allows you to create this kind of stuff. Now think about Java 30 years ago. If they did not put as much forethought into their design as this, right, what would be the consequences of that? Right? 30 years later, we would be fighting the bad design. This is well designed, right? We would be fighting that design today. Many languages are like that. We used Python earlier. We used Python 3. Has anybody used Python 2? All right, you have? One, like when?
I first installed Python, didn't know what I was doing.
Oh, okay. I installed 2 by default. That's weird. Because Python 2 has reached the end of life end of life support, and they don't even support it anymore. And why do we have these 2? Well, at some point, it was just ad hoc. People would just throw things into the language without much of a thought, right? And it got to a point where they said, okay, there's too much bad design. We're going to go ahead and wipe out that old language, create Python 3, keep the good stuff, redesign the bad stuff, and now it's no longer backwards compatible. You cannot take Python 3 code and expect it to work unless it's extremely simple in Python 2. PHP is also guilty of this, right? Java bends over backwards to be backwards compatible because they do not want the last 30 years of code to break. They design things well, for the most part, right? Well thought out design so that they're not breaking things or fighting that design later on. You're going to want to make sure that you have the same good design. Otherwise, you're going to be fighting your own design, or you're going to be redesigning it. And if you have to redesign it, everything breaks. You have to go back and fix everything, right? Instead of changing one class, you now have to change 5 classes or 10 classes, all right? All right, any questions about inheritance? We've got a couple minutes here left. So let's go ahead and go with some pitfalls here. Like I said, everything should be well designed up front. If you don't, you'll have things, have problems like the rectangle problem. Oops, sorry, should have been over here, right? And to do that, so here's the rectangle problem. Let me take you over, let's close all these things. Come on, there we go. And I've got it over here, and there we go. And let's look at the way that I've designed this. It looks fine at first. Square. Is a square a rectangle? Yes, technically. All right? A rectangle only has to have 2 matching sides and 2 matching sides, but a square has all 4 of them are matching lengths. Right? And is a rectangle a shape? Yes. And by transitivity, hopefully you're talking about transitivity eventually in 235, a square is a rectangle, and therefore a square is a shape. Right? But now let me show you how this can break. I'm going to go ahead and create a square, a 10 by 10 square. Its area is now 100. But then I have this setter here. I can set the height. That's defined in the superclass. Is S a square anymore? Not technically. It's 5 by 10. But is it an instance of square in my Java language? Yeah. So even though it is no longer a square, it's still a square. Right? This is a violation of what's called the Liskov substitution principle. Right? Your objects have to be in an inheritance hierarchy, always have to follow that is a relationship. Let me move all that over there. And if they don't, for example, our ill-defined author, director, person, that wasn't a great design when we put it into an inheritance hierarchy because it doesn't allow you to have a person that is both of those things. Right? This is, again, an example of a violation of the Liskov substitution principle. We'll talk about the solid principles after we've gone over polymorphism. And again, prefer composition over inheritance when you have this situation. There are some clear situations where you do put it into an inheritance hierarchy, and hopefully it's abundantly clear with our project description. Right? Another problem is the yo-yo anti-pattern. Right? So it was a kingdom, order, phylum, genus, what blah 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 blah. I think that was 7 layers deep. Right? And that makes sense when you've got something as complex as the animal kingdom, right? But what happens when you've got a very, very deep pattern in your inheritance hierarchy? Oh, by the way, what's an anti-pattern? I think I've talked about it before. It's a common but bad habit that you see in code, right? So it's a common pattern that is useful, and a pattern is the opposite. It's a common pattern that is useful and good design. Did anybody do the builder pattern in your lab last week? No? Okay. Go back and check it out. Remember I was talking about the builder pattern? That's a good habit to have, right? Deep inheritance hierarchies, say you're 20 classes deep, are also really bad, right? Why are they really bad? Because you're always looking at this hierarchy, even if it's just a diagram, and you're thinking, all right, I need a property. Where was that property introduced in the hierarchy? And you go up, oh, there it is, right? Now I need more specific behavior. So where does this specific behavior come in? Oh, it's down here, right? And so you're always going up and down this really, really deep hierarchy, and you're bobbing your head up and down like you're watching a yo-yo go up and down. And that's why it's called the yo-yo anti-pattern. So in other words, when you're designing things, keep it shallow, or, once again, prefer composition over inheritance. It gets you the same and similar benefits of code reuse, but without locking you into that hierarchy. Okay? One last anti-pattern is the diamond anti-pattern. Right? This is really only a problem with C++, right? That allows you to inherit from multiple classes, but it's actually now a problem in Java too, because they changed some of the things about how Java works. Here's my example. Suppose X, let's say X, extends dog and cat. What is it? So remember, we've got an animal, we've got a cat, and we've got a dog. So there's my inheritance hierarchy. But what if I've got this thing down here that inherits from both of them? This is called multiple inheritance. What is that thing? What is X? What is X? Right. More importantly, what does X say? Does it say meow? Or does it say wolf? Question mark. Which one? Right. Well, if you were to do this in C++, you'd have to write code that says, oh, I will inherit the speak method from the cat class, and so it says meow, right? But you have to write code anyway to do that, so why are you inheriting from both of these things, right? It's called the diamond anti-pattern. Why? We've got animal up here, dog and cat, and then we've got X down here. What shape did I just draw out, right, in space there? That's a diamond, right? Java does not allow this, which is a very, very good thing, right? Even in C++, you would have to disambiguate it, right? You'd have to either read the manual and say, okay, well, what does this do, right? By the way, the answer is it's just a freak, right? Although, at least as of a couple of years ago, I never saw it because I wasn't a kid at the time, but there's a cartoon called Cat Dog? Or Dog Cat, or what is it called? Cat Dog? Okay, Cat Dog. So, and what does it look like? One end is a cat and the other end is a dog, right? And so it's just a freakish cartoon, right? So what is it? It's just a freak, right? We don't want to do this. We want to make sure that we are only inheriting from one, and Java does that for us. Even in C++, you definitely don't want to get into this pattern, right? Java gives you all the benefits using interfaces without any of the headaches of what do we inherit from what, right? Because everything that you end up inheriting is an abstract function or an abstract method that you end up having to implement anyway, right? So those are just 3 anti-patterns. When we come back on Wednesday, we're going to talk about polymorphism. And I'll just give you the definition now. All right? Poly is many, and morph is form. Right? You've done this already before. You write one piece of code that can be applied to any type. For example, malloc. Right? Malloc just generically allocates memory for you. You can use it for doubles. You can use it for integers. Sorting. Have we had a sort method for doubles and a sort method for strings and a sort method for books and a sort method for sort method? No. We've had one sort method to rule them all. And that's what we're going to do here. Right? We're going to write generic code that can be applied to multiple situations so that we don't have to write a version for every single type. And that's actually going to turn out to be the most powerful part of object-oriented programming, right? Especially in Java. All right? So when we come back, we'll do that on Wednesday.